Good morning, students. I am M. Venkataya, Assistant Professor in the Department of Mechanical Engineering at Vigyan's Lara Institute of Technology and Science. Now I am going to teach the subject is thermal and hydro prime movers. So this is in the previous class what we have discussed is already in the properties of steam and uses of steam table, that is TS and HS diagrams. TS means temperature and entropy, okay, and the HS diagram, that is enthalpy and entropy values diagrams, and this is the TS temperature and entropy values. So here T equal to temperature and the S equal to entropy, okay, and the H means enthalpy, S means entropy, okay. So here already this topic is already completed, that is properties of steam. So the properties of steam and uses of steam tables. After completion of that one, the TS diagram and HS diagram also completed. So analysis of various thermodynamic processes undergone by a steam. So various thermodynamic process undergone by a steam, that is first one is constant pressure, second one is the processes will be 4 processes is there. That first process is constant pressure and constant temperature, then constant volume, then adiabatic process, okay. So that is the thermodynamic processes undergone by a steam. In this steam, so 4 processes is there. The first process is the constant pressure, second one is constant volume, third one is constant temperature, then adiabatic process. So the adiabatic process is nothing but that is that there is no heat into the system and outgoing the system. So adiabatic process already Q equal to 0. So that is the adiabatic process. Now the vapor power cycles are also completed, that is the Carnot cycle. In this Carnot cycle we are already calculated the derivation as well as the problems already completed in the first unit. So then here the second unit we are discussing about the Rankine cycle also completed, and reheat cycle, thermodynamic variables, effective efficiency and output of Rankine cycle. So analysis of simple Rankine cycle and the reheat cycle. So these are also completed in the second unit, okay. So this is the main. Now I am going to explain today's class is the steam turbines, that is the systematic layout of steam power plant and the classification of steam turbines like impulse turbine and the reaction turbine. Here the classification is 2 types of classification is there. That is the first one is impulse turbines and the reaction. Second one is the reaction turbine and comparison component, that is the comparison relation between the impulse turbine and the reaction turbine in turbines, okay. Velocity diagrams for simple and impulse and reaction turbines, then the work done and efficiency of the reaction turbine as well as the impulse turbine, okay. These are the syllabus. Already the first part is completed, then the second part will be there. In this class I have discussed the systematic layout of steam power plant and classification of steam turbines like impulse and reaction turbines. After completion of that one, next class I will explain the comparison between the impulse turbine as well as the comparison between impulse turbine and reaction turbine. Okay. Then the velocity diagram for simple impulse and the reaction turbines work done, and the efficiency of the thermal efficiency of the impulse turbine and the reaction turbine. Okay. Next, this is the systematic layout of power plant. Okay. Today's class have discussed the systematic layout of steam power plant and the classification of steam turbines, impulse turbine and the reaction turbine. Okay. So this is the general layout of steam power plant. So we have to see here. This is the thing we are using here. The steam power plants we are using the Rankine cycle. Mostly we are using the Rankine cycle. So that's why we have taken the Rankine cycle systematic layout. So we have to see here. This is the general layout of steam power plant of exactly the Rankine cycle. This is the Rankine cycle. So here this is the pump. So this one is the pump. And the work in. So work in here, the pump will be there here. So this is the 1 to 2 process. So here then the Rankine cycle we have 4 processes, that is 1 to 2 process and 2 to 3 process, 3 to 4 process, 4 to 1 process. Okay, this is the adiabatic expansion, adiabatic expansion, 2 to 3 heat in, and 3 to 4 adiabatic compression, then 4 to 1 is heat out. This is the thing. So here the process of Rankine cycle is 4 processes is there. That 4 process is 1 to 2 process, that is the expansion, adiabatic expansion, and 2 to 3 process heat in, and 3 to 4 process, that is the adiabatic compression, and the 4 to 1 process, that is the heat out. Okay. So this is the thing. So this is the work in, and this one is the pump. So 1 to 2 process, that is the adiabatic expansion. So we have the water with the help of water, water will send to the boiler. Okay, water will send to the boiler. Boiler in the inside the boiler the heater is there. So heat in. When the heat in, then the steam will be sent to the turbine. So turbine have some blades, that is here the 2 different types of turbines is there. That is we are using here 2 different types of turbines. One is a simple impulse turbine, and second one is reaction turbine. Okay, so here the water will steam boil. When the water boils, the steam will be produced, that is a vapor. So that vapor will send to the turbines. So here we are installing the 2 types of turbine which we want to anything, that is a simple or reaction. So that turbine that have some blades. So when the steam is enter into the turbines, the blades will be rotated. When the blades will be rotated, at the time the shaft will connected with the turbines, that is the shaft will connected with the turbine. Then the shaft will rotate. Then the rotates in the end of the shaft, that has a electromagnetic fields will be there. With the when the shaft will rotates, at the time the power will produce at the time that has some energy. That energy and magnetic field will be installed at the shaft end of the shaft. So here the some power and magnetic field, the power will be there. So at the time the power will be produced. that power will transfer to transformer. The transformer will send to which one we want power, they can supply. Okay, this is the main thing of systematic layout of power plant. Then heat is out, so that is the heat is out, that like power, so it is transferred to transformer. This is the thing, and once again this is the condenser. This is the circularly, this is the regularly rotation process and the recirculation process of this general layout of steam power plant. And we have to see here, this is the temperature and entropy. So this is the temperature in T, entropy S. So this is the in x-axis entropy, and this is the y-axis temperature we are installing here. So first 1 to 2 process, and 2 to 3 process, then 3 to 4 process, and 4 to 1 process will be there. 1 to 2, okay, 2 to 3, 3 to 4, 4 to 1. Okay, so this is the boiling point, and water, steam, isomeric, vaporization, superheated steam, dry steam, wet steam, adiabatic. Adiabatic in the sense of there is no heat into the system and outgoing the system. We are discussing in the first unit, that is the IC engine, open system, closed system, and isolated system. So isolated means adiabatic. So for example of adiabatic is thermoplast. So that is the thing. And this is the general layout of steam power plant. So steam power plant converts the chemical energy of the fossil fuel like coal, oil, gases, or uranium, thorium into electrical energy. So the main concept of the power plant, we produce the power. The main concept of power plant, the main concept of power plant, steam power plant, or to produce the power. Okay, so that is the general layout. This one is the steam power plant, converts the chemical energy. So converts the steam power plant, it converts the chemical energy of the fossil fuels like oil, coal, gases. Okay, so our gases, if you take gases, and if you take oil, and if you take coal, or fuels, that is uranium, teluranium into electrical energy. So the main general layout and steam power plants, what will tells is, it converts the chemical energy to the mechanical energy, and mechanical energy to the electrical energy. That is the thing. Okay, and this is the steam power plant basically works on Rankine cycle. So basically works on Rankine cycle. So this is the main thing we are using here in the steam power plants and steam turbines. So we are using the Rankine cycle. Rankine cycle have 4 processes, that is 1 to 2 process, 2 to 3 process, 3 to 4 process, and 4 to 1 process. Okay, so 1 to 2 process adiabatic expansion, and 2 to 3 process, that is the heat in. Okay, and the 3 to 4 process adiabatic compression, and then the 4 to 1 process, that is the heat out. So heat out means we produce the power. Okay, that is the thing. And the steam is produced in the boiler by utilizing the heat of fuel consumption. Okay, so the steam is produced in the boiler. The steam will be produced in the boiler by utilizing the heat of fuel consumption. Okay, utilizing the heat of the fuel consumption. Okay, then this steam is expanded. So this steam is expanded through the steam turbines. Okay, this steam is expanded through the steam turbines. Okay, through the steam turbines. The steam turbines derives the generator which converts the mechanical energy of the turbine into electrical energy. So the turbine what will happen here is the generator which converts. So main thing is the generator, we discussed in here only. So the generator, so first of all this steam is expanded through the steam turbines, okay, expanded to the steam turbines, and the steam turbine derives the generator which converts the mechanical energy to the electrical energy. So the main function of the generator, what is mean by main function of generator? So the generator is the mechanical energy, it will convert to the electrical energy, then we can say that generator. Okay, the main function of the generator is the mechanical energy will convert to the electrical energy. So what about the motor? What is the main function of the motor? The motor is the electrical energy will convert to the mechanical energy is called the motor. This is the fundamental thing. We should know the fundamental thing of motor and function of motor as well as the generator. So what about the generator? Generator means, what is the meaning of the generator is the mechanical energy will convert to the electrical energy is called the generator. What about motor? Motor is a nothing but a motor is a device. Okay, so the motor is a device that motor electrical energy will convert to the mechanical energy, that is called motor. Okay, is it clear? So mechanical energy of the turbine into electrical energy. Okay, then this is the steam power plant layout of steam power plant. We have to see here. This is the general layout of steam power plant. So finally we achieve the power. Finally we achieve the power from we get the power from power plants. So here this one is the cooling tower. This one is the cooling tower. Cooling tower. And this one is the stake. This one is the stake. And this general figure, and this one is the main part of the power plants. This is the general layout of the power plant. This is the already we discussed in the boiler. Okay, turbine and electrical generator. Okay, so warm water. This is the warm water. This is the cooled water. This is the cooling tower. What is the main function of the cooling tower? So the cooling tower to cool the water. So when the heated water will be there, so that will water will send to the here. That is a cooling water, means cooling tower. We are using the cooling tower. So then the water will be cooled. Okay. So after completion of that one, the feed water pump. This is the feed water pump. We get the from suck. We collect from this suck. Then the this fluid or water will send to the boiler, and this is the heater will be there. This is the heater will be there with the help of heater in the inside the boiler. Inside the boiler, the water will be heated. When the heated the water, then it will send to the turbine. Then it will send to the turbine. Which send here is the steam will be sent to the turbine, and turbine will rotate. Turbine blades will rotate, and the shaft will connect it to the turbine blades. That shaft at the end of the shaft, the electrical generator is there. That generator will mechanical energy will transfer to the electrical energy. So with the help of generator, and the magnetic field will be there, then the produces the power. Then it will produces power. Then it will produces power. So that when the producing the power will transfer to the transformer, then transformer will transfer to the which they want required the power. They will send to the each and every aspects. Okay. Then this is the general steam power plant basic principle. So we have to see this is the hole, that is the water coming inside, and this is the boiler. Within the heater is there, that is the heat the boiler, and the waste gases will send out, and this is the process of mechanical energy. This is the mechanical energy will be transfer the turbines. The main function of the turbine is to rotate the blades, to rotate the radially rotating, and the blades will connected with the shaft. Shaft will connect it to the generator. So that is the turbine. Turbine will connect it to the generator. This one is the condenser. All this is the generator. So this is the condenser, alternator or condenser, and the finally grid. This is the grid. Okay, electrical energy rises. So the chemical energy, the main function of this is the chemical energy, that is the fuel, will convert to the mechanical energy. Then the mechanical energy will convert to the electrical energy. This is the main steam power plant, the basic principle. Okay. And then this is the major components of steam power plant. So we have to see here, this is the first one is the boiler. Boiler is the most important, but the main function of the boiler is to boil the water. So to boil the water with the help of heater inside the heater. Okay. Then the reheater. So reheater is the most important because of to boil the water with the help of heater. Okay. Then economizer and condenser, superheater, air preheater, and steam turbine. Steam turbine, two types of steam turbine, that is the simple impulse turbine as well as the reaction turbines. This is the simple impulse turbine. Simple impulse turbine and the reheating reaction turbine. Cooling towers, it is a very important thing here, that is a cooling tower also. And what I have discussed here, once again I will repeat once again here, the components of the main components of the steam power plant. The main components of the steam power plant is, so the first point is the boiler, and the second is the superheater, and the reheater. Third point is reheater. Okay, reheater. Then the air preheater. Okay, air preheater. Fifth economizer. Sixth turbines. Okay, seventh condenser, and the eighth one is cooling towers. Okay, so this is the sequence, and the boiler, reheater, economizer, condenser, superheater, air preheater, steam turbine, cooling towers. Okay. Then another components will be there here. That is circulating water pump. Okay, the circulating water pump, boiler feed pump, generator, water treatment section, chimney, and control rooms. Okay, so the ninth point is circulating water pump. Okay, circulating water pump, boiler feed pump, generator, water treatment section, and chimney and control rooms. Okay, these are the power plant. These are the major components of the power plants. Okay. Then, so the layout of steam power plant will be discussed by means of three circuits will be there. That three circuits is, first one is furnace circuit, second one is steam circuit, third one is cooling water circuit. Okay. So the three circuits will be there. The layout of steam power plant will be discussed by means of three circuits. That three circuits is furnace circuit, second one is the steam circuit, third one is cooling water circuit. Okay. Then we discuss the first of all the furnace circuit. Then before feeding of the furnace, the coal is to be converted into the pulverized frame, and after combustion. So the before feeding the furnace, the coal means we know that the coal to be converted into the polarized form, and after combustion the ash is to be collected into the ash pit. Okay, and then the steam, second one is steam circuit. That steam circuit, the water present in the boiler is heated up by means of a furnace and has the density. So here once what we have to observe is the water present in the boiler is heated up by means of a furnace and heat as the density of steam is less than the density of water. This is the main point, main important point. Okay, then the steam will deposit on the surface of the water. Okay, is it clear? And the last point is, that is the cooling water circuit. Okay, the cooling water circuit. The cooling water, it is used to condense the steam in the condenser as supplied from the cooling tower. Okay, this point. And coming to this point, the hot steam cannot be released directly into the atmospheric. So what is meant by atmospheric pressure? So atmospheric pressure, this is the surroundings. Surroundings will be there. In these surroundings, we have to say that how much pressure will be inside the room or outside the room. The pressure will be called as inside temperature, or temperature in point of view. Temperature is nothing but the pressure, that is atmospheric pressure. Okay, so from the chimney, and doing so the hot steam will after the atmospheric pressure. Then for this reason, the hot steam along with the water particles was released from the larger heights in the cooling tower, so that the water will fall down and the air particles will escape into the atmospheric pressure. Okay, so after burning of the coal, it is transferred to ash handling plant and finally to the ash storage. Okay, finally to the ash storage. This is the sequence of circuits, and three types of circuits, that is the cooling water circuit, furnace circuit will be used in this power plant. Okay, then this the finally the summary is today's what we have discussed is, that is the first thing is the layout of steam power plant. Layout of steam power plant. And the classification of steam turbines. Okay, next class I will discuss about the classification of steam turbines, and that is the impulse turbine, simple impulse turbine, and the second point is reaction turbine. Okay, so and then the next class I will explain the simple impulse turbine, the reaction turbine, and the difference between the simple impulse turbine and the reaction turbine. After completion of that one, so I have to do the explain of work done and efficiency of the reaction turbine as well as the simple impulse turbine. Okay, thank you.